Hey,
Hi,
Jan.
Michael.
How do you do?
I'm fine. What about you?
Very good, very good. And I've double checked. People can hear you now. Okay.
Okay.
Yeah, the last two times we've tried this, for different reasons, the audio from
hmm
Discord was not making it onto Twitch or
Well,
into the
I
recording.
think it was, but it was very, very soft.
Yeah, and that was actually because the microphone was picking up the audio from my headset. that was
Okay.
that was all that was making it on there. Um,
Okay. No, it's quite complicated to get
mhm.
everything broadcasted.
Yep. Yeah, I mean, you actually have to take a look at the meter to see if everything's working.
Mm. Michael,
Mm-hmm.
um, a suggestion.
Sure.
Just up to now, we have been learning all the time. But would it be useful if we would, from next week onwards, uh, turn around a little bit the roles.
Mm-hmm.
I don't, I don't mean you learning from us. That's not possible. But actually, I think I'm far enough to start building a small model,
Mm-hmm.
to use Jinaga to try it out, to
That
start
would be
in
awesome.
Java and to start in JavaScript.
Mm-hmm.
I've still been digging a little bit in it, and I start understanding it.
Uh-huh.
So for the moment, uh, just React, no React Native, no TypeScript, just JavaScript,
Mm-hmm.
and then try things. Um, and why not? It's about 3/4 1 hour session that we say, okay,
Mm-hmm.
the people who want, they can just, for example, during 10 minutes, explain to the others what they have been doing, and see what the others think about it.
Mm-hmm.
Jeff might tell me, Jan, what you've been doing there is stupid. You have a better solution. You might have feedback. So these things will help me to improve,
Mm-hmm.
or the others who present.
Yeah.
Um,
And that will help me too because that way I can see what sort of issues people are running into, and then maybe we can
hmm,
fix the documentation, we can fix the API, we can make things better for people that come behind us.
yeah, because in that way, because we have been listening now all the time,
Mm-hmm.
um, perhaps finally we can we can do something. Um, no, but we have to start at a certain moment,
Yeah.
and at a certain moment you just have to start to continue learning.
Yeah, I like that. I really like that idea. That's
It's an
that's going to be
idea,
fantastic.
but I
Mm-hmm.
don't know whether Luke or Jeff, they want to build things already, but I want to try to
Mm-hmm.
convert my application, um, for the technicians on the road, to historical modeling.
Mm-hmm.
And
Yeah.
I think the best way to start is uh, to try with Jinaga, to start building the model, just Jinaga,
Mm-hmm.
JavaScript, and React. Then as we go, add a little bit TypeScript when I'm more familiar with JavaScript. TypeScript should be easy to add on, and then try a little bit with Reactive Native. Once I am more familiar with Reactive, and
Okay.
that then I have the whole picture. And the next step could be translate it to .NET and see what
Mm-hmm.
Xamarin has to bring into it. Um,
Yeah. In fact, we might just go ahead and skip over the React Native part of that and just get the model figured out in Jinaga with React, and
mhm.
then um, start building out the .NET support that's necessary in order to get that model translated to .NET. Um,
Yeah.
because yeah, I think React Native is unless that is the target, and we already talked about reasons why in this particular application you probably don't want that to be the target. Um, but unless that is the target, then I think the work that we would be doing in order to get that up and running would just be throwaway. We wouldn't really learn anything from it. But the work to get the model working in React, I think, is going to be pretty valuable. So
Yeah,
yeah, I think that's
because
a good idea.
the fact that Jinaga works with React, and React is a whole new system, no, but it gives additional possibilities, which I don't know from the C# world. So I'm interested to learn a little bit more about React anyway.
Yeah. Although if
But
you're getting into Razor borrows a lot of the same concepts that are used in React. It does them differently, but things feel a little bit familiar. So.
And then about React Native and Xamarin to work on the mobile phones. Is it still your opinion that Xamarin is better, or?
It is, and that's still based on the maturity of it. Xamarin's been around for a long time, and they've got a lot of things ironed out. React Native is still feeling a little bit bumpy to me.
Okay. I've never done anything on mobile except native, directly on Android in Java. So I don't know the other platforms.
Yeah, and that's another big part of it is you know .NET, you know Xamarin. Yeah, it's productive for you, so let's target that. And and there are lots of other developers out there that are comfortable in Xamarin and C#. So it just makes sense to create a Jinaga that supports them as well. So,
okay.
So yeah, I think that's the
because
right
what Microsoft is doing now with .NET 5 and actually .NET 6 next year, that should be a big step forwards to mobile platforms as well.
Yeah, I think so. I think it's finally time to to dust off that branch and Assistikent where we tried to make it work with .NET Standard, and it's like it ran into some kind of problems. I don't remember what they were, and then I was like, well, this isn't really buying us much anyway, so let's hold off on this. Well, yeah, now with .NET 5, it's like definitely need to get Assistikent ported to .NET 5, and I think it's going to be a lot easier than it was trying to get it on Standard. Okay. So I think I was starting to do that on .NET Standard 1.1, and then
and then let's hope that Microsoft in 2 years' time they don't say, "Oh, we cancel that."
I know my friends still bring up Silverlight in my presence, and it makes me sad.
Sometimes I think if everybody would just stick to one platform, but then there is no competition. If there is no competition, there is no progress anymore.
And there's no diversity. There's no new thought. There's no let's try this experiment. Then that's what.
Yeah, but it's nice. It's nice as a game. But to be productive and to make a business out of it, there are too many platforms.
Well, as a developer of a brand new platform, I really can't I can't take the opinion then as an application developer that, hey, there are too many platforms. It's like, well, I'm developing a new platform because I think there's this new idea that really needs to be explored. But then, at the same time, I get what you're saying is that while we're trying to build the Jinaga platform, that's a data management platform. And then we've got runtime platforms, and we've got user interface platforms, and they're all just all over the place as well. So while we're trying to build this data management platform, it's like, okay, and then we have to make it easier for an application developer to pick their UI platform and their runtime and hook them all together.
Yeah, but even the languages, on Android, they work with Java. Then a little bit later, they came with Kotlin, and then Google. It was Google who started with Flutter,
Right. Yep.
Yeah, and then for Flutter they don't use Java or Kotlin. No, they start with Dart.
Yeah.
Yeah. Well, I mean, it would if they just would say that there is C# and there is JavaScript. Yeah, these two, and that's it. And perhaps it's not 100% perfect for everything,
Mhm.
but it would be very productive, I think.
Yeah.
But okay,
But the world
then
would
there
be a
is
very dull place.
then there is no fun anymore.
Yeah. Okay. Well, so welcome, Luke. What Jan and I were just talking about is starting next week. If you're ready, Jan,
Mhm.
we can start. Yeah, Jan is going to start developing an application using Jinaga for JavaScript, and then we can see if everything is going to go well with that. Yeah, we can learn from that experience, and then use that then to transition into Jinaga.net. Um, so yeah, this will be more of a a multi-dimensional stand-up rather than just a broadcast from me to everybody.
Now it will be very slow and very basic in the beginning. Don't expect to see a full application next week.
Yeah,
But
but despite all that, here is an application that we can use to talk about just a second. I'm trying to get things working well for the stream. Okay, there we go. Yeah, so here is an application that we can use to talk about how to get Jinaga set up. So in the past couple of weeks, we were talking about a real application that did all the complexity of the real thing, and so this one is pretty pared down and makes it easier to just kind of talk about getting Jinaga set up in an application and see a very simple model. So the model in question is, if we go to GitHub / Michael L. Perry / feedback. Okay. I thought it was called, oh, it's Jinaga feedback. That's it. Jinaga / feedback. There we go. So this is a project that I started, yeah, you can see 10 months ago, in order to build a very simple but very useful Jinaga application. So this one is all about capturing comments on a blog and being able to respond to them. So the idea being that if, like me, you run your blogs with something like Gatsby, then you've got a static content site that's served up to the user, so it's really fast, but that means it doesn't have a backend and it's not serving dynamic content like comments. And so when doing that sort of thing, you need some other engine to serve up that dynamic content and attach it to the static content. And so that's what this feedback application is all about. So the model for feedback is that we've got our Jinaga user identified by a public key, and then the feedback site is created by a user, that user being the blog's author or initial creator. So so that feedback site is further identified by a unique ID, a GUID. So that way that author can create several different sites. And
Michael,
mm-hmm.
Sorry to interrupt you, but we just see the code now on the stream. We don't see the model.
Okay. Thank you. I forgot that Discord shares windows and not screens. So I have to switch to feedback. There we go.
Okay, that's better.
All right. Yeah, so yes, github.com/Jinaga/feedback will get you to the repository. So the model that this sets up is you've got a user identified by a public key. The site is identified by a unique ID created by a user, and then the domain is a successor of the site. So that's using the mutable property pattern. So it's saying that I can use a string in order to to assign that domain property to the site. And so with this prior arrow here, that means that we are referring back to the prior settings of that domain. So that's just a way of setting a property on the site object. But the more interesting part of this is so we've come down this path here where we had a user and the site that they created. Here we'll have a different user. So this will be somebody who visits your site and wants to leave a comment. So they'll have some mechanism by which they can log in so that they can identify who they are while they're leaving their comment. And so after they get logged in, then they will have a public key as well. So then they will navigate to a page, and so that page will be content. So this is the content refers to the content that you're actually publishing as an author. So a blog post or something like that. So, some page on your site. And so you've got the path that identifies that content. So that's the URL. And then the comment is now a fact that the author creates on that particular content page. So the comment has a unique ID. And then we've got comment text. That should actually be comment text, not content text. So comment text is, again, using the mutable property pattern. So it's pointing back to the prior versions of content text. And it's just capturing a value as a string. So a pretty simple model, but this is probably the simplest model that does something really useful and collaborative. So you have somebody that's producing content as one user and somebody that's commenting on that content as another user. And so that connection there allows them to collaborate. So I happen to have an example running over here. So Gabriel Iglesias has come to my site and said, this is an awesome site. So I wanted to show what the code looks like in order to get this comment section appearing on the site. So, any questions about the area and the focus that we're looking at? Okay.
It's clear.
All right. So let's start with the. I'll go ahead and clean all this up. So we're starting with the application, and so I started this by using one of the starter kits that you can find on Jinaga.com, and then under source that creates client, server, and shared. So the server stuff just runs on the server in Node. The client stuff runs in the browser using React.
Michael, and now we still see the website. We don't see the code.
Thank you, yes. Okay, so let's change to the app. Okay. I'm going to have to
That's
remember
better.
to do that. Okay. So yeah, under source, we've got client server and shared. Under shared, I just have the model right now. But this is another place you could put other code that you want to be loaded into both the front end and the back end. But so far, just the model. And so the model has things like, here's the user. So as we saw in the diagram, which I won't flip to because that'll take too long, is that the users had the type of Jinaga.user, and username is a mutable property on user, and here it's feedback.user.name. There's a reason that I won't go into that the user is always of type Jinaga.user. But then from that point forward, all of the facts are within your own namespace. So feedback being the namespace. So yeah, this is just saying that a user has a field public key, and so all of the fields of the class go to make that thing distinct. So if I create a user fact with a different public key, I've got a different user. But if I create a user fact with the same public key, it's the same user. So that entire set is the identity of the thing. Kind of more interesting is if we go to the site. Here's the site created by a user. It's got a unique ID. We're just capturing that as a string. Here's the domain. We talked about that being the mutable property pattern. So for a particular site, what's the value of that domain, and then what are the prior domains? That way, when I change the domain name of a site, which I should be able to do, then I create a new site domain and I capture the current one as prior, and now that makes this one the current one. And it's an array because I can have concurrent changes, and then I can resolve those conflicts by having multiple priors. And then also the first one has an empty array. So that's the mutable property pattern there. So more interesting still is content. So content is something that's on a site with a path. So now I can, when I navigate to a page, the Gatsby application, that static site generator, should be able to say, well, here is the unique ID of this site. So you can create the site object, and then looking at the URL that they just navigated to, okay, that's the path. Stick that in there, and now you've got a distinct content object that represents this page on the internet. And then going down one more level, comments. So a comment has a unique ID, and it is on a content page by an author, and this is a different user. So just simply leaving a comment creates this object, and it's got its unique identifier, but you can see it doesn't have the actual comment itself because that is supposed to be able to change. So comment text is the mutable property pattern now applied to comments, where so for this comment I've got a value, and here are the prior comment text, and so that way we can capture those as mutable properties. So that's how the model starts out. We just define those structures, and then we start to evolve the application by creating instances of them and using them within queries and projections. So next I'll show you how we start down the React route and start to consume this model. Okay, so moving from shared, let's go all the way up to the client. So here is how you begin any React application, is that you're going to use React DOM in order to render a component into the page. So the page is right here, index.html. So it's going to grab all of the stuff that it needs, but then right here, it's got the application host, and so that div becomes the container for that component. So that marries those two things together. And then what a component looks like, if I take a look inside of components, here is app.tsx. And this is the application component. So I know we talked a little bit about React a couple of weeks ago. Just kind of as a refresher here, you see a bunch of angle brackets inside of what looks like a JavaScript or a TypeScript file, and that's the X in TSX, is that it's adding the ability to put components to put angle bracket stuff inside of JavaScript, and so that stuff for the most part looks like HTML, but sometimes it can refer to JavaScript functions and classes, and that's what the components are. So in this case, we've got this empty. This is really just open close. So an empty component. This doesn't render out a div. This truly just takes everything that's inside of that and renders that all wherever it belongs. It completely disappears at runtime. But doing that allows you to have multiple components in here. As it happens, I just have one, so that was unnecessary. But we can see that the application component, it's going to return a content container. As it does so, it's setting up a little bit of state. So right here, what we're doing is we are creating a variable that will maintain state within this application component, and that variable will be of type content. So that content is, if we navigate back to it, that is the content fact. So I want to be able to keep track of that variable. Set content becomes a function that now I can call in order to change the variable. So it's a little bit of a strange pattern when you first see it. What React is doing is using immutability, big fan, in order to keep track of its application state. So this content variable right here, for the duration of this function, is immutable. It is a constant. When you call set content, what you're going to do is pass in a new value for that content variable, and that's going to cause React to call this function again. And the second time through, this content constant will have that new value. So each time it calls this render function, the values are constant, but you can change what they get initialized to from one call to the next. So is that something that y'all have kind of already grokked in React, or is that kind of a new concept?
A little bit, but it still surprises me.
Yeah. Yeah, it is a surprising way to do things, and in fact, having the ability to declare variables like this inside of a function component is a relatively new thing to React. It's only been around for a couple of years. But that is quickly becoming the preferred way, unless you're using a state management system like Redux. Yeah, of course, if you go with state management, just store everything in the store. But still, every once in a while, you have to do this just for local state. So the whole idea of this is that we want this application to be a part of some content. So we want this particular page to render the comments that were left for a particular piece of content. And in a real application, you would have this change as you navigated from one page to the other. And so even in a statically generated sites using Gatsby, you could have components that stick as you navigate from one page to another. So this app component would stick, but the content that it refers to will change. And so you'll end up calling set content on navigation in order to now render the content for or the comments for a different piece of content. In this particular application, all we're doing is we are initializing the content on first render and then just keeping it. So use effect is the React way of invoking some some behavior whenever the source state changes. And in this case, the source state that we're talking about is an empty array. So this is an idiom for saying just call this function only on first render, and then don't worry about it anymore. So that means when we first render the application, we are going to call make content, which is right up here. And you can see that is asynchronous. So if I hover over it, I can see that's a function that returns a promise of content. And so it's going to run asynchronously. When it's finished, I can call then, and then now takes a function that takes that content that was just returned, and set content is exactly that kind of function. It's a function that takes a content and returns void. So this is basically going to call an asynchronous function. When the asynchronous function is finished, then it will call set content. So all that's kind of just getting past to the React idioms for how to declare a variable and initialize it. So if you can just say, okay, let's put the confusion of use state and use effect aside, and all I'm trying to do is call an asynchronous function and use that result to initialize a variable, then now we are actually talking about the Jinaga stuff. So what we're doing right here inside of this asynchronous function is we are just creating a bunch of facts. So here I'm going to create a new user fact, and this should be an RSA public key, but right now I'm just faking it out. And then this is the site that user has created, and here I'll give it a GUID. So every time you come to this site, it's the same GUID created by the same user, therefore it's the same site fact. So j.fact will load the existing one from the repository, or create a new one if it doesn't exist yet. And then this user is the visitor to the site. So this would be a different RSA public key that we would pass in here. So if you take a look at the documentation and at the groundhog coding videos, you'll see how you can log the user in, and then you get this user object with their public key already populated in there. but that's basically what would be happening here. Is this would be wait j.login. And so you've got this the visitor, and now you can say I want to set the mutable property on that user of username. And the way you do that is by creating a new username fact. So you say this visitor's name is Gabriel Iglesias. So so usually what would happen here is you do a j.login. It's going to go out to your OIDC provider, and it's going to say, okay, this is the person who's logged in. Here's their identifier, and here's a little bit of information that I have about them, like for example their name. So once you get that back, you can take that profile information, that name, and create this username fact. So now we're getting down to the meat of the actual application, is that here we want to create a content object for this site. So we've already created the site from this user, and then we take the path to the content. So this is what we would get from window.href or from your routing system. So your React router. So that is the path that represents that unique content on your site. So now you've got your content object, and now we're simulating Gabriel Iglesias writing a comment. So he creates a comment fact. Here's the GUID that he creates for it, for that content as that visitor. And then right here he sets the comment text to this is an awesome site, with the empty array, meaning this is the very first version of that text. So all of that just builds a graph. It's pretty much the graph that we just saw in the example there. This is what the database would contain if we had a page on our application and somebody were to come to that page and leave a comment. So does all of that make sense? Okay.
Yes, that's pure historical modeling.
Yeah, exactly. Exactly. And yeah, I'm just going to geek out on this for just a second. What I absolutely love about this is that it is solving like 2 or 3 or 5 problems all at the same time. So first of all, j.fact, it's going to retrieve the existing one if it's already there, or create a new one. So this is how you point to a record in the database, or insert it if it's not already there. But then this is also storing it locally, in case you're using this as a PWA and you're keeping things offline, and it's calling an API to send it to the server, and it's causing the server to store it in its database. So all of that can be expressed by just simply creating a fact. So that's the end of the geek out there. Okay.
So the facts are stored on the server, or
Mm-hmm.
Our intent, our projections are sent to the server for the server to know which facts we want.
Right.
And
Hold
the
on 1 second.
facts
Sorry.
to be exchanged between users.
Her car in the shop as an emergency.
Mm-hmm.
If I take her my car because she's got to go to the car doing at work, can you pick me up? Do you have a chance to?
Yeah. I don't have anything to do this evening, so in fact, I think I can go get you and be back by 4. I think is my next.
Okay, because all I need to do is put some clothes on that I don't look like a homeless person and run over there real fast.
Yeah. Okay. Yeah, and then when I'm done with here, I'll go get you.
Okay, sounds good.
Okay.
Right, we got a plan.
All right. Emergency plan making. I love it. Okay, so yeah, you were talking about the facts are stored on the server. The projections are so we
Maybe one more time. We have 2 users leaving comments on the site. We have a server that is its main job is to exchange facts. Yes.
Correct.
So if I leave a comment, I mean I create this fact. This fact is stored in my database locally and sent through the server to another user, which wants this fact.
Yes, and
I still didn't get it. Why this is stored on the server? Because I thought previously that the server the main job for the server is just to exchange, to be able to register to the server that I'm interested in particular facts, and the server will just exchange those facts between users. So he would take just fact from my database and send it to another user, something like that.
Yeah.
Or I'm wrong completely.
You are absolutely right. I think the thing that you're just forgetting is that the users might not be on the site at the same time. So somebody can come leave a comment, go away, then somebody else can come to the site and read the comment. So then it has to be stored on the server.
One question, because you mentioned bookmarks in the book. So I thought that it's just a pull model, and I will keep bookmarks for other servers, user databases. I keep bookmarks for each one of those databases, and through the server, I would just pull those facts and fix my counter of those bookmarks. Fix those bookmarks. I mean.
Yes. So the bookmark is stored on the client. So in this case, you've got a progressive web app. The client maintains state, and so when the client comes back up, connects to the server, now it knows the last time that it talked to the server, and it can say, hey, what's new from this point on, and the server can just simply go through its storage and answer that question. It's almost precisely the same thing as having a shared Git repository, a remote, and you do a Git pull. So you just say, all right, server, this is where my branch is right now. What has what new commits have happened since that point?
So on the server are all the facts.
Yes, exactly. Yeah, so just for exactly the same reason that you would have a shared repository in Git that stores all of your commits, you have a shared server that has all of your facts.
Okay, I thought differently a little bit, but okay, I understand. So it's like a Git.
Yes. Yeah, very much. In fact, that started to become kind of my default. It's like, oh, I'm trying to explain things. Well, it's like Git. So, okay. And Git is so complicated, but yet we've already gone through all the effort to understand it, and so now just saying that is like, oh, okay, yeah, I got it. Yeah. So, and in fact, we are going to see in just a little bit how the client expresses interest. What is which facts is it interested in? So when we make the content that's returning the content fact, and so that way asynchronously when it's done, saving and sharing all of those facts, now it's got the content and it just calls set content, which causes the application to render now with the content fact in here. So that gets us into our content container. So diving into content container, this is a Jinaga React container component. So one of the patterns that you'll often see in React is that people will sometimes subdivide components between those that have interaction and behavior and style and layout and all that stuff, and those that are just there to contain other things and to run application logic. So I've used that pattern here. It's not strictly necessary, but it makes it cleaner to have this discussion. And so this is the container side of that. Starting right here where we entered, we've got the content container. Well, that is a container component that Jinaga itself creates for us. So Jinaga container is a factory method that will create a React component. And so you give it J, the instance of Jinaga, basically the reference to your local storage and to your API, so that you can interact with the server. That's all encapsulated within J. That's the same J that we were using, by the way, back here, in order to say j.fact. So just storing all the stuff into that graph. Here's the graph, so that now we can start to retrieve stuff from it. So create a container wrapping that graph, and then we use a mapping in order to map some properties to some components. So what does all that mean? Well, here is the mapping, which we create by calling map props to. So map props takes a specification, which these days I would call a pipeline. And we talked about specifications last week. So we take that specification for what are the queries that we're going to run, what are the properties that we want, and then we map those properties to a React component. So this component takes comments, which we expect to be a child component, and then it renders them inside of this container. So now we have a container that's got the comment header and then the actual comments component. So how is the comments component defined? Well, that's inside of the comment specification defined right here. So this is a specification starting at content. So if you remember, the fact that we passed in here was a content fact. So that's the one that it's going to start with. And it's going to now run some queries. So j.for, that means that we're going to run a template function and then see which facts match that template. So we're looking for the comments for that content. So I've got the content, the page that I'm on, and I'm looking for all of the comments that were posted to that page. So just simply run that query, get all those comments, and then we're going to map them to some child components. So I'll dig into this template function in just a little bit, but I want to continue up this this page, and we can see here we've just cycled around in the recursion. So before we were talking about, here's a container starting at one fact using a mapping. And now here we are mapping a collection of the responses, of the results of a query to another mapping. So here's the mapping. I want to map the properties from comment specification to this React component. So it's a React component that takes the these three properties defined in that specification, and it just renders out a comment block. And so comment block is the thing that has all of the interaction and the layout and the CSS and all that good stuff. And so all we're doing here is grabbing that data and passing that in as properties to that comment block.
Run locally only, or on the server too?
This is all locally, yes.
Locally.
So that kind of gets into what is happening with this collection and J.4. Is that first it's going to serve that information out of the local storage, and then if it can connect to the server, it will go ahead and talk to the server and say, I'm interested in comments for this particular content fact. So here's a pipeline starting at that content fact. I want you to run that and give me back the results. When they finally do come back, then the client side is going to store those results and then update this query. So initially you'll see the comments that you already have stored, and then after a short delay, calling the server and getting the results back, then new comments will appear.
Okay.
So just kind of rounding out this story, this map props, it's mapping this comment specification. So remember here we had a specification for content, so this was for the page itself, and that ran a query that gave me back comments. So now I'm mapping from the comment to all of its properties. So I'm just recursing one level lower. So from here, I'm going to grab a whole bunch of information about a comment. Some of that is just directly there on the fact. So here, I'm just grabbing the comment itself. So that's the comment itself, the identity function. Here, I want the author of the comment, and that's a user. So comment.author is just a user fact, and I'm going to grab that and send that to the user property, or to the author property. So those two are fixed, they're immutable. As soon as you have executed this, you have a comment object and you have an author object, and they will never change. These others will change as a response to new facts that affect these queries. So I'll start with this one. This one's the easier one to get your head around. The property helper is going to run a query. So I'm going to get the author of the comment, and then now that I've got that author, which is a user, I'm going to get the username for that user. So this is going to run a couple of queries and just append them together. So it's building that pipeline. So in effect, this is just going to figure out what is the name of the author that created this comment. And so I'll get back these username facts, and the one that I want to display, the one that I want to actually map to author name, is just the value field of that fact. And then this right here is the default property if I don't yet have one of those. So this, if you remember, we saw this same property function yesterday, last week, when we used this in order to project some JavaScript or some JSON. So it's it's the same type of thing is happening here. Is that we're going to run this query, get back the results, take the value as the one that we're interested in, or an empty string as default, and that string is what we'll get back in author name. So that's the author name that gets now sent back in here as a string. So
okay, and if I leave a comment on a site, and the second user wants to see this comment, he needs to refresh the page, or will be informed by the server that the new comment exists, or he needs to run this query to see these comments?
Excellent set of choices there, because that is exactly the things to think about. So when you do your typical API type application development, you as an application developer have to know when to call the API. So you have to run the query. Here Jinaga takes care of that for you. So Jinaga knows that whenever something happens to change the results of this query, like for example the user changes their name, or the results of this query, like somebody new posts a comment, then Jinaga will take that, invert the query, say, okay, that affects this part of the user interface, and then update that part of the user interface. So you don't have to think about when do I run the query, when do I update things. But you gave three options there, and I love that you broke it down into three options. Does the user refresh the page? Does the application developer rerun the query, or does it all just happen by magic? There's one more step in order to get to the magic part, and that is to subscribe, because that is just expensive enough that I don't want it to be the default. So if, as an application developer, you say, I really want to just show comments as they appear, then you would, in a different part of your code, subscribe to this query. And in fact, you would flesh it out with an entire pipeline and subscribe to that whole pipeline. And so now, anytime somebody posts a comment or changes the comment or changes their username, then it's published to your application, and then it just all refreshes. Now, in this application, I didn't subscribe, so that means after we've run it, the application is no longer going to be getting that information from the server. It will be integrating new information that it receives on the client, and I'll show you why that might happen. But yeah, the upshot is that without subscribing, the user would have to refresh in order to see new comments. So that's a decision that you as an application developer make in order to decide, is it important that I see this in real time, or do I be more performant and not have those WebSockets that are open all the time?
It's clear now.
Okay, good. Yeah, I know there's a lot happening there, and excuse me. What I've tried to do is just encapsulate the things that can truly change from one application to another, and put those in your control. But then the things that are always the same, they are abstracted away. So yeah, the things that are important to your application are your model, your queries, your projections, and what it is that you subscribe to. So your optimizations, or your performance characteristics, and then the things that are the same for all applications. All applications are interested in saving data back to the server. All applications are interested in the capability of running queries. They're all interested in updating the user interface when those results change. So those are the things that are just automatic.
If we have a graph of facts locally and a couple of pipelines also locally, without interacting with the server, we still have possibility to refresh parts of the page locally also.
Yes.
Because we add, for example, new fact,
Mm-hmm.
we don't want to recalculate all the pipelines. Yes.
Exactly. You're absolutely correct. So one such example is right here with the comment text for the comment. So I'll go over the mutable helper method in just a little bit, but let's dive into what does it mean for to get the comment text for the comment, and then we'll see how this leads to the user themselves changing a thing that then they can immediately see. So comment text for comment. If I drill into that, that is a template function that starts at a comment, and then it matches comment text with that comment as the predecessor. So I'm looking for just any comment text facts that were created on this comment. It then has this such that comment text is current. Well, is current is defined right there. So that is a predicate that starts with the comment text, and it tests to see that there does not exist another comment text where this one is in its prior collection. So that's an idiom that that you'll follow, and you'll basically implement that is current method for every mutable property that that you define. So does that expression make a little bit of sense?
Yeah, I understand mutable property mentioned in the book.
Yep.
I'm just thinking about, because if we edit a comment, add a new fact, but we see on the screen a list of comments as a result of the query. And now we add a fact, so we still need to recalculate this query because we add this new fact, or we can just update one comment in the list of comments.
Right, it'll just update one comment in the list of comments. And there are two things that are happening to make that work. One is query inversion. So that's what Jinaga is doing in order to say, okay, I see a new comment text. So who depends upon that? And so it's going to say that this query right here depends upon that new comment text. This query for a specific starting point. That's the whole reason for doing the inverse, is to get back to that starting point. So it says, okay, this comment text, let's invert the query. That's the comment that we need to update. So Jinaga is taking care of that part.
It will drill down to this comment.
Yes.
And this component.
Yes.
And after we add this new fact, it will just re-render this one component.
Yes, exactly. And that just re-render that one component, that's where React takes over. So React, even though your programming model is always top-down, you're calling all the render functions, what React is actually doing is computing the output of that render function, comparing to what's already on the screen, and then making the minimum change necessary in order to update the screen. So
okay,
yeah, those two things. Yeah, yeah. It sounds like magic. It's actually algorithms, and it's just really well thought out algorithms. So the first one is the query inversion, where we say new fact. Okay, change that one thing, and then the other side of that is React. Okay, let's render the or figure out what the tree should look like. Okay, that's the one thing that should change, and then just change that one thing. But yeah, both of those things are happening in order to get you the behavior that you need. So if we dive into the comment block, so remember the whole purpose of this is, and hopefully, Lucas is back. So the whole purpose of this is to get these properties and pass them into this comment block component. So here is the actual comment block component. So now you can see here's a bunch of stuff that actually looks like HTML. So far we've just been calling other child components. Now we're actually rendering out some HTML. And so we've got our classes. This is actually just class, but we have to call it class name so that we don't use the keyword. But yeah, that's the HTML or the CSS class. And so we're just rendering out the information in here. So like here is the comment text. I have that inside of this dangerously set inner HTML thing because I'm going for a markdown rendering. That's not complete, and that is dangerous, as it says right there. But the idea is that it's going to render that the text of your comment. And then right here, we're going to render the author name. Well, we're going to pass it down to another component which renders the author name. So we've got this nesting of components where all of the data that it's going to render comes in from the properties. So the properties that we're expecting are self. Is this a comment for the person who's currently logged in? If so, give them the edit button. If not, they can't edit other people's comments. Author name, that string, that's the result of the query that we ran. What is the name of the author of this comment? And we're going to put that on the screen. What's the comment itself? I'm sorry. This is... Yeah. So this is the comment fact itself. And then what is the comment text? So this is the results of running that query. And it's kept inside of this mutable wrapper. That way we can tell what's the current value of it and what are the priors. How do I create a brand new one? So right here, when I want to edit and then save a new comment, then I'm just going to call j.fact and create a new comment text, and then set the value of that new comment text, and then you get the prior collection from this mutable property that I started with. So that is going to change the value of the comment text by creating a new fact. So just by doing that, then that means that it's going to be saved locally, it's going to be sent to the server, and it's going to run the query inverse locally and figure out what needs to be updated. So just saving that re-renders the component and updates the comment text for that component, which we can see right there. There's the actual value that it pulls out.
As a developers, we need three things. So JFact to create new facts.
Mm-hmm.
This part of HTML we want to render.
Mm-hmm.
And the third one is query itself.
Yes.
And that's all, because everything else will be run by Jinaga locally or on the server.
Right, exactly. Yeah, everything else is application agnostic. The database doesn't know your schema. That's application agnostic. The API doesn't know your schema, so it's always just saving facts and running pipelines. The only thing that changes from one application to another is what you just listed. The model, the queries, the user interface, and that's the only thing that you have to specify.
Okay, and is it possible to run a couple of servers?
Yes, it is. Yeah.
Is it something hard? Because if I understand, we can register to. So the server is able to recompute, inverse the queries, yes? And if there are multiple servers, and this graph of facts will be somehow synchronize between them. I can't imagine how you did it.
Yeah.
Managed
So
to do it.
so that's so that part of Jinaga JS is not yet complete, but it would be following the patterns that are outlined in the book. So there's some work to that area, and if I flip to the server side, we can see that a little bit. So here's Jinaga config that runs on the server. So we just call Jinaga server.create, and in this particular application, all I'm doing is setting up the authorization rules. But there are other things that you can set up, like the Postgres key store and factual store connection strings. I actually took those out for this demonstration so that I could just restart things and clear out the database, because it's all just stored in memory on the server. But that's where you would configure those. This one right here, HTTP endpoints, that is the Jinaga endpoint for another server. So now you can create this topology where you've got the servers that are chained together. And so whenever you run a query against this server, it will run that query against the other one, update its local storage, and give you back the results as well. So so that is the starting point for how these things are going to serialize. The next step is to have them in a peer-to-peer backplane. Because right now it's this one talks to its parent, but to have a backplane where they discover one another, and then they as one receives facts, it's able to share them out with the other peers in that network, and they merge them into their graph, run their query inverse, and see who's interested in that, and notify them.
It sounds complicated, but doable.
Yeah, and yes, that algorithm is going to be a little bit complicated. Two things going for it. One, because it's an algorithm written on top of an immutable data structure, we can start to take advantage of some of the benefits of immutability. So using set unions and using the idempotency of immutable facts. So all of those benefits that I talk about in the book, you're now able to build the synchronization system on top of those benefits and take advantage of them. But then the other thing is that, again, this is completely application agnostic. We write this once into Jinaga, and then every application can take advantage of it. You don't have to write a synchronization system for your application specifically.
Okay. Nice.
Yep. So that's the vision there. And then here on the server, after it sets up this Jinaga server, it gets back a handler. This is an express handler, and so it just exposes that handler at /Jinaga. So now that becomes the endpoint that the client uses in order to execute the entire API, which is also the same endpoint that a different server could use in order to synchronize with this instance of the server.
Our server is using the same query inverses like run locally? I mean, same algorithm to compute those inverses?
Yes, in order to do the notification. So if you were to subscribe to this Jinaga server, then it's going to use those query inverses in order to tell you when something that you're interested in has arrived at the server.
Okay, but this code is shared. So if I run locally those inverses, and on the server will be more data. I mean, larger tree of facts, but those inverses will be calculated using the same logic. I mean, algorithm.
Mm-hmm. Yeah, the same algorithm. And so that algorithm is encoded within that Jinaga package, which is used on the on the server side as well as on the client side. So that same thing with those same endpoints, or with those same algorithms used in both places. Yes, exactly.
I have a last question. Is Jinaga feedback a good place to start with? So it looks like MVP, like demo. We can play with it because this fact model is not large enough, but it's doing the purpose.
Yeah. In fact, let me switch back to. I'm going to switch to the browser, and okay, so yeah, the Jinaga/feedback project is just the model, and I was breaking this down into different sub-projects. So then there's another sub-project called Jinaga feedback-react, and so this is just the React user interface. But in order for you to just get this and start playing with it, I will point you to the code that we're actually looking at today is Michael L. Perry / feedback-app. And I have not moved this to the Jinaga organization. It's still on my own organization because I really want to give a good demonstration of an application using Gatsby that then takes Jinaga as a plugin, and I've encapsulated everything there. But for today's demonstration, I really wanted to have all the pieces in the same place. So I brought everything together inside of the application and said this is what we're looking at today. So yeah, that's why you'll see inside of source, here's our shared model. So yeah, if you clone that one, then you should be able to get that running. And so like I was just saying, it doesn't use a Postgres database. You can turn that on with a simple configuration setting, but that way you can start playing with it without installing Postgres and running the scripts, which are described right here, if you do want to go down that route. But you don't have to do that in order to get everything running.
Thank you, Michael.
Yeah, welcome. Yeah, so yeah, because of all that, then Gabriel Iglesias is able to come in here and say, not this is an awesome site, but this is a really awesome site. Save that, and the user interface updates. In addition to that, let me go ahead and show you what's happening over the network. And this is a fantastic site. So when he saves that, we just had one message go back to the server. Save is saying, here is the payload. Here is the graph of facts that I just saved. So you remember we had this directed acyclic graph where we had the user that creates a site, and the site contains content, and then we've got this other user that is posting to the site. So they create a comment, and then these comment texts are the history of the prior comments. So it takes all of those facts in order to build the graph. But then once it's got that graph, then it is uniquely identifying this comment right here, where the fields, the values, this is a fantastic site. So so that's what save always looks like. No matter what your application is, it's just going to take your facts, put them into a graph, and then send that to the server for the server to run the query inverse, save it to its local database, notify anybody else who's interested in these facts.
This is a simplification because you are sending the whole graph each time.
Yes, and that is necessary because of the transitive closure on the predecessors. So there is a possible optimization that I haven't yet implemented in Jinaga, and you'll notice right here the hash. If the server already knows the fact that has this hash, then it doesn't need the fields or the actual list of predecessors or the type. It just says, okay, that's the hash that we're talking about. So this list of predecessors right here, like here's the comment. It's just the hash and the type. So a possible optimization is for the client to understand what the server already knows, because it's already done that bookmark call back with the server. And so under that optimization, it would be able to send just fact number 7 here. So it says, well, I already got these from the server. It already knows about them, so I'm not going to send them back again. I'm just going to refer to them by their hashes. So yeah, there are some optimizations that we can make. And again, once we make those optimizations, everybody gets them.
Because these optimizations, they were already available in correspondence.
That is, I believe that is true. Is that true?
Because in correspondence, we only send through the new facts, if I remember well.
Yes, yeah, I think that is true. Yep, and so that's really just some work that needs to be done on the client side in order to understand what's what's known. I think, if I remember correctly, this API will just work on the server side if this array only contains this one fact. It's just that the client doesn't yet understand that it doesn't need to send the others. But yeah, the server is going to do the right algorithm.
The reason you send it like this is because you didn't have time to do the optimization, or because it doesn't really improve efficiency, unless you have mutable properties which change all the time. If you have a name of somebody who has been changed for 10,000 times, well, then the graph gets very big. But
yeah, I would say that it's really because I haven't had time to implement the optimization yet. So it's still a really good idea to limit your use of things like the immutable property pattern that will give you this long chain of history, and favor patterns that are going to give you a broad tree. In those situations where you can't optimize out your predecessor closure, then that's still going to be helpful to you. So yeah, I would say that in this type of application, you would expect somebody to change their comments very infrequently, and so you would expect the tree to be rather shallow. But if you were using mutable properties to represent state, and state changes all the time, well, then you're misusing mutable property. Use the state pattern. That's what that's for.
And if it will be more comments, it will send all of them to the server, or just one of them?
Right. So before the optimization, it'll send all of them to the server. Once we get that optimization in place, then it'll just send the new one. But there are situations that you can imagine, well, actually, like when you first land on the page and you load all the comments, it's going to load the entire graph from the server. So it still makes sense to have rather shallow graphs.
Okay.
Awesome. So I believe that is everything I wanted to talk about today. I do have to execute on the emergency plan and go pick up my wife. So my daughter's car just just conked out, so she had to go get her, and now I need to go get both of them. Or yeah, she needs to leave her car and then go bring her back.
Yeah, that's what daddies are for, to help daughters.
Yeah.
Okay. So thank you, Michael, for today.
Yeah, quite welcome. I really really enjoyed this, and I am looking forward to Jan starting to to build an application using Jinaga, and so even though there's a lot happening under the covers and there's a lot of complexity, I hope that you'll find that that the things that you are responsible for taking care of become understandable and simple enough. I've found that when working within this system, I am extremely productive, but it doesn't start out that way. So I'm looking forward to seeing what what roadblocks you run into, and then see if we can get those out of the way for the next person.
Okay. See you next week.
Indeed.
Thank you very much.
Thanks.
Bye, Michael. Bye, Luc.